Hello, in this session we evaluate the energy level diagram alongside the Hess's law of constant heat summation. Welcome. What is the energy level diagram? An energy level diagram is simply a diagram known as the Haber cycle. It represents the stages of a chemical reaction between the reactants changing into their respective ions and in gaseous state before they form the final product. So assuming that we want to find the enthalpy of reaction leading to the formation of ethanol from its pure elements, we begin from the basic level, which is our level 1 of reaction, in which the pure elements forming ethanol, including carbon, hydrogen, and oxygen, combine to form what is required, in this case, ethanol. Remember, the equation has to be fully balanced, and when you look at it, that is a balanced equation forming ethanol. Now, once we have represented the principal equation, which is the enthalpy of formation, we proceed to the next level. And the next level is ensuring that all reactants are ionized. Now, before they ionize, if it's a solid, it has to first change into a gas. So in this case, carbon will sublime and give us heat change of sublimation. In the same way, hydrogen, which is a molecule, will dissociate. And when it dissociates, it gives us atoms instead of molecule, and we maintain the numbers. Thirdly, oxygen will have to dissociate towards a half a mole, so it will just give us one atom in the gaseous state. Now, once we have moved from level 1 to level 2, where all reactants have been transformed into their gaseous form, into their gaseous states, we proceed to level 3, where the gaseous atoms are transformed into their ion forms. In this case, carbon will change into carbon ions in the gaseous state. Hydrogen will change into hydrogen ions in the gaseous state. In this case, they're combining mainly as non-metallic species. And then we have oxygen, which is currently 1 mole, also ionizing into oxygen ions. And the final result of this is our level 3. At level 3, the 3 principal substances interact with one another and they combine readily, forming a gaseous product, C2H5OH, which is ethanol in the gaseous phase. Beyond this, we would have to condense the ethanol for it to exist in its natural state. So the natural state of ethanol is a liquid, so it will have to be C2H5OH. In this case, it is aqueous through the process of condensation. Now, since this is a level which is intermediate, we will want to complete the cycle, which is the Haber cycle. And this will represent a delta H equivalent to 0 of the Haber cycle. Now, we have a delta H ionization of carbon, a delta H ionization of hydrogen, a delta H ionization of oxygen. So, in a nutshell, each process proceeds into 3 distinct levels, beginning from the base, moving upwards. Now, according to what we have referred to as Hess's law of constant heat summation, we saw that the enthalpy change for the direct path should always be equivalent to the enthalpy change for the indirect path. Now, let's see if this is our direct path, represented by enthalpy of formation. Then our indirect path will be all the other subsidiary reaction steps. leading to the formation of the required. And in that case, that is the indirect path. If we complete it to the bottom, that is it. We would say delta H direct path is equivalent to delta H indirect path. And that is in respect to Hess's law of constant heat summation. Now, to quantify the required value, we would have to proceed systematically by representing the Hess relationship, which I want us to do together. So we are going to take it, the reaction at this point, if you allow me to bring this closer. So the reaction at this point begins with a formation. So we can say comfortably that our delta H formation, which is a direct path, should be equivalent to the sum of all the other delta H's. So in this case, we have delta H sublimation plus delta H ionization. And in this case, it's ionization of carbon. Then plus delta H dissociation of hydrogen plus delta H ionization of hydrogen. Proceeding to the next, we have plus delta H dissociation of oxygen plus delta H ionization of oxygen. Then we have delta H reaction. So if you allow me to proceed there, we have delta H reaction. Then beyond that, we have delta H condensation. And then the delta H0. So with this representation, our aim will be simply to quantify the required value, which is delta H reaction. Now we have all the other values given, as you can see down here, except the enthalpy of reaction. So by substitution, we are going to simply add all these values and then subtract from the main value, which is the delta H of formation, to enable us obtain the enthalpy of reaction. Let's see how this is going to be. So we are going to say principally that we have delta H formation. Our delta H formation has been given. So in substitution, I think that will be much easier. As we substitute, instead of delta H of formation, we'll simply write the value, which is 2130. Instead of sublimation, we write the value, which is 502. Sublimation, 218. Ionization is 502. Dissociation of hydrogen is 87. Ionization of hydrogen is 104. Dissociation of oxygen is 83 kilojoules. Ionization of oxygen is 101. And delta H reaction is unknown. So the unknown we transform into X. Now, proceeding to the next level, we have condensation, which has been given. And this condensation has been given as 1127. So we add 1127, and then plus the subsidiary between ethanol aqueous and ethanol liquid, which is 0. So as we quantify these values, what we end up with is a relationship of the form 2130 is equivalent to what we are seeing as X plus 2222. So we make X the subject. In this case, we have 2130 minus 2222. And what do we get? Our X value is found to be equivalent to negative 92 kilojoules. Negative 92 kilojoules. This negative 92 kilojoules is the enthalpy of reaction. Of the reaction which is forming 1 mole of ethanol C2H5OH. Now, since it is forming 1 mole, we can say it is negative 92 kilojoules per mole. So, in summary, we can conclusively say that Hess's law is applicable in the energy level diagram in as much as it's applicable in the energy cycle diagram. Both are in this case referred to as the Born-Haber cycles. The Born-Haber cycle is the energy level or energy cycle diagram. Thank you.